Today I'm going to be showing you how there are 5 Platonic solids, and to do this we have to ask ourselves how many nice polyhedras are there. And by nice I mean there are one type of side and each of the sides is a regular polygon. So to answer this question we have to look at nets. So say we're looking at a cube, we're going to make it flat because we understand 2D shapes way better than we understand 3D shapes because it's easier to look at. So now we're going to just look at the vertexes. So we're just going to look at these where the faces meet. And since the shapes are the same, the number of vertexes will always be the same. Even if it only looks like there's 2 right here, once you fold it up into a cube, it will be touching 3 faces. So 3 faces is at every vertex. So even if you have a quarter, so a quarter of the cube, which is going to be like this. This is why 2 faces wouldn't work, because if you just folded it up, it would just be a piece of paper. It wouldn't be it wouldn't fold up into a shape because there's not 3 faces at the vertex. Now we know this because we have 2 rules. The first rule is at least 3 sides. And the second rule is no more than 360. Or I don't mean no more than 360 because it would be no more than 359 because it can't be 360 degrees or over the sum of the total or the sum of the angles in the shapes. We know that because we have to leave space for the shape to actually fold up. So now we're going to look at equilateral triangles and the number of sides at the vertex and the sum of the angles. So number of sides at vertex and angles. But we have to look at, we have a formula for the angles of a regular polygon, and I'll explain it really fast so we can get on to the video. So say we're looking at a square, we're going to cut it into 4 triangles, kind of like this. And each of these triangles have 180 degrees. However, we're only trying to measure out here. And so that would be 90, 90, 90, 90. So we don't even, or not 90, that it would combine up into that. But since we don't care about the middle, that's 360. So our formula is going to be 180 degrees times n minus 360 over n. And an easier way to write this is 180 minus 360 degrees over n. And the top of it is the total amount of degrees, and the n is the number of sides. So we're going to go back to the equilateral triangle. So we're going to start at 3 because we know that 3 vertexes is the smallest one. So we're going to do the formula. So it'll be 3 times 60 equals 180. So 180 is smaller than 360, so that one checks off. 4 times 60, and 60 is the number of angles on each vertex. That would be 240, which checks off. 5 would be 5 times 60, which checks off because it's 300. And then 6 would be 6 times 60, which wouldn't check off because it's 360. And that's more than 359. So one with 3 triangles meeting at the vortex might look like that. 1, 2, 3, 4. That might be what the 4 looks like, and if you add another one, that would be what the 5 looks like. So these all work because they all have space to pull up. So the only possibilities are 3, 4, and 5 because 3, 4, and 5 vertex share, or 3, 4, and 5 faces share the vertex. So we're only looking at one of these, but in reality they would have like a lot of these combining. So now we're going to just look at, instead of equilateral triangles, we're going to look at cubes. So if we're looking at squares or cubes, we're going to have another with the same number of sides and angles. Oh, this is supposed to be angles. Not angels, angles. So now we are going to start at 3 because we know 3 is the smallest, and we know that each vertex has, or each of them have a 90 degrees, so we're going to times 3 times 90, and this formula is basically what's over here. And that would be 270, so that one would check off. And 4 times 90 is 360, and that's more than 359, so that wouldn't check off. So that leaves us with 3 would work for squares. Now we're going to do pentagons. And we're going to start at 3. It'd be 3 times 108, because that's the angle for each. And then it would be 324, which should check off because that's smaller than. These are the 2 main rules that we're basically narrowing everything down. And now we're going to try hexagons. So we're going to do 3 times 120, which equals 360. So we know that doesn't work. Oh wait, I forgot to circle the pentagon of 3. That works. This one doesn't work, so hexagons do not work. And again, we started at 3 because that's what rule number 1 says. And we're basically done now, because if we look back at the formula right here, as n gets bigger, the fraction will get smaller, which means the number being subtracted will get bigger with the more sides added. So it will just keep going up above 360 and higher. So now we have 5 things to consider. So we know that 3, 4, and 5 work for the equilateral triangles. We know that 3 works for the squares, and 3 works for the pentagon. So we've narrowed it down to those 5 shapes or Platonic solid, and we know they work because they actually do exist in life.